Hi everyone, and this is Mr. Zarzak, and in this screencast I'm going to show you how to deal with the acceleration of objects in a system. Alright, so the system that I'm talking about here is I have these two blocks that are tethered together via a pulley. So block B is hanging over the edge of the table and it's going to pull block A along with it. Alright, so our job is to figure out what's going to be the rate of acceleration of block A and block B. Note up here I've got it written down that we're going to assume that the tabletop is frictionless. Okay, so it's an ice table or block A is a hover puck. Okay, so this is, believe it or not, it's going to make the problem a little bit simpler to solve. We can do it with friction, it's just a tougher problem. Okay, so this problem is hard enough as it is. Alright, so what's going on here? Alright, well, because they're tethered together by this rope, okay, well, that means that if they move together. So imagine in your mind kind of like A and B are really just two cars of a train and B is the engine. Okay, and that's kind of the trick with Newton's laws. Specifically, Newton's second law says that the net force acting on an object or a system of objects will cause those objects to accelerate. That's really what F net equals ma means. Okay, so our job is to figure out, okay, what are the force or forces that are going to cause our objects to accelerate, and what objects are we talking about? All right, so if I look at my picture, okay, well, the key to all of this is gravity. See, so block B here is going to get pulled down, okay, by this thing that we call the force of gravity. Let me make a nice arrow here. It's for the screencast, okay? So the block of this is the force of gravity. Okay, that's the weight of block B. Okay, well, the way that we would get the weight of block B is we would take its mass, so I take the mass of block B, and then multiply that by the acceleration of gravity. All right, so let's go ahead and do that really quick. Let's see, over here, block B for me is 3 kilograms, so I have 3 kilograms. Okay, times gravity. I'm just going to use 10 just to keep our numbers as simple as we can. Okay, so the weight of block B is 30 newtons. Okay, so what I have here is I have a force of 30 newtons that's pulling down on block B. I'm going to take this, let's take and sneak this over here just to get it out of our way. We'll put that there. Okay, and then I'm just going to label this as the force of gravity equals 30 newtons. Okay. Now, if we just were to drop block B, we would see it accelerate downwards at 10 meters per second squared. It'd be in free fall, see, but it's not because it's attached to block A. All right. And block A, it moves sideways. It doesn't fall at all, but what it still has is it still has mass, which means it still has inertia or resistance to acceleration. Okay. And that has the result of it's going to reduce the acceleration of B, because B's got to tow A, okay? If you've ever like towed a trailer or a boat with your car, you know that, well, like the car doesn't pick up as well because it's got to drag all that extra mass of whatever it is that you're towing. Well, that's exactly what's going on here. The net force, okay, that's going to be the force of gravity. This force here is doing all of the pulling for both of the blocks, okay? So let's take this. Let me just move this over so I got a little bit of space, all right? So I've got this 30 newtons of net force here. Okay, that's doing the pulling, but that's going to cause both the blocks to accelerate. So this mass that's over here, okay, is the mass of block B and the mass of block A together. It's got to do the pulling for both blocks, all right? So when I sub in for my mass, okay, I got to add those masses together. So I got 9 kilograms for block A, and I have 3 kilograms for block B, and together those two blocks will accelerate at some rate. So now the problem's not too tough. I have 30 on the left is equal to 9 plus 3, that's 12, times my acceleration. So to solve for the acceleration, I just divide by 12. Okay, so let's see. So 30 divided by 12, let's see. So 12, 24, 36. So that'd be 2.5. 2.5 meters per second squared is equal to the acceleration. Okay. So again, just to recap, okay, the first thing I needed to do was I needed to recognize that block B's weight is pulling them both. So I calculated block B's weight. All right, once I did that, okay, then I went and I applied Newton's second law and said, you know what, that 30 newtons of pull is responsible for pulling both. That's my net force. Okay, and then the key is to recognize that it's pulling both masses. Okay, the 9 and the 3 kilograms or whatever your two masses are together, and then from there, it's just algebra. All right, and there's our answer. Hope that's useful to you. Thanks for watching, and I will see you next time.